Hello students and good afternoon. So now I am doing class for class 12. The topic is relations. So in the last online class also we did some problems on relations, that is types of relations. So there were some problems regarding reflexive relation, symmetric relation and transitive relation. So today we will do more problems on these relations. Okay, same type of relation, that is reflexive, symmetric, transitive relations, and today we will do equivalence relations also. Okay, so let's start this question number 7. In the last online class we did question number 6. So let's do this question number 7. So question number 7 is, so that the relation R, this R is the relation on R real numbers. This R is the real numbers. That is, this relation R is defined as R is equal to within second bracket A comma B such that A less than or equal to B. Such that A less than or equal to B. A may be less than B or A is equal to B. Is reflexive and transitive but not symmetric. त तिमीले यहाँ के प्रुभ गर्नुपर्छ? This relation R is reflexive and symmetric but not you have to prove that the relation R is reflexive and transitive but not symmetric. Okay, so now for reflexive relation, you have to check A comma A should belong to the relation R. Okay, so here in this case A less than or equal to A. Yes, this is true. This is true because A is equal to A is also given here, so this is true. So therefore the relation, because A is equal to A, isn't it? A is equal to A because is equal to relation is also given out here. If it is only less than mattai bhako bha chai hune thiena. A is not less than itself, isn't it? So that is not a reflexive relation, but is equal to relation is also given there. So A is equal to A. So this is true. So the relation R is reflexive. The relation R is reflexive. I think you have understood it. Okay. Now let us check for symmetric relation. Symmetric relation. So what is symmetric relation? A comma B belongs to the relation R should imply that B comma A belongs to the relation R. Okay, so now in this case A is less than or equal to B, but does it imply B less than or equal to A? Does it imply? So B less than or equal to A does not hold good, isn't it? That is, B is not less than A. Is that clear? Suppose if you have 2 less than 5, can you say that 5 less than 2? No, that is wrong. 5 is greater than 2. So therefore in this case B comma A does not belong to R. If it is A less than or equal to B, can you write B less than or equal to A? No, that is wrong. So B comma A does not belong to the relation R. So the relation R is not a symmetric relation. Therefore the relation R is not a symmetric relation. The relation R is not a symmetric relation. So I think I've understood it. So you can copy it. So now we will check for transitive relation now. So you can copy it. Now we will check for transitive relation. Now let us check for transitive relation now. Transitive relation. So what is the definition of transitive relation? If A comma B belongs to the relation R and B comma C belongs to the relation R, which implies that A comma C should belong to the relation R. So if the relation given here is A less than or equal to B, if A less than or equal to B and B less than or equal to C, let us take three numbers here, A comma B comma C. These are the three real numbers. Can you say that A less than or equal to C? So which implies that obviously it is A less than or equal to C. Like if you have, suppose example, if you have 2 less than or equal to 5 and 5 less than or equal to 10, isn't it? 2 less than or equal to 5, 5 less than or equal to 10, they are given. Can you say that 2 less than or equal to 10? Obviously it is 2 less than or equal to 10. Is that clear? Is that clear to all of you? This is also an example. So here, if A comma B belongs to the relation R and B comma C belongs to the relation R, so A comma C belongs to the relation R. So it will imply A less than or equal to C, isn't it? If A less than or equal to B and B less than or equal to C, then it implies A less than or equal to C. So the relation R is a transitive relation. So therefore, the relation R is a transitive relation. The relation R is a transitive relation. So we have proved that the given relation R is reflexive and transitive but not symmetric. So is that clear now? So you can copy it. Now we'll do the next problem. So now we'll do the next question, that is question number 8. Check whether the relation R on R dash, real numbers. This R is the relation and R dash, this R dash is the real numbers. Defined by the relation R is equal to A comma B such that A less than or equal to B cube. But in this case, this A comma B belongs to the real numbers. A comma B belong to the real numbers. So you have to check whether the relation R is reflexive, symmetric or transitive. So let us check it now. So for reflexive relation, so what can we say about reflexive relation? Real numbers भनेको positive integers, negative integers including 0. Also you can put the fractions also, fraction पनि हाल्नु पर्छ यसमा, or within square root positive numbers. These are all defined numbers, that is known as real numbers. Is that clear? So now let us check for reflexive relation now. So for reflexive relation, you know that A comma A should belong to the relation R. त्यस्तै number, same numbers हुनु पर्यो. A is related to itself. Okay, so now let us check it. If you put A is equal to 2, the B पनि 2 नै हुनु पर्यो, same हुनु पर्यो हैन? The A less than or equal to B cube, that is, which implies that what is A? 2 less than or equal to 2 whole cube, which implies that 2 less than or equal to 2 whole cube is 8. तर यो होल नम्बरमा यो ट्रू देखाउँदैछ, 2,2 मा ट्रू देखाउँदैछ, 1,1 मा पनि ट्रू नै देखाउँछ, 3,3 मा पनि ट्रू नै देखाउँछ. अब हामी फ्र्याक्सनमा चेक गर्छौं. केमा चेक गर्छौं? फ्र्याक्सनमा पनि चेक गर्नुपर्छ, किनभने फ्र्याक्सन इज अल्सो अ रियल नम्बर, यु नो दैट, इजन्ट इट? सो अब हामी फ्र्याक्सनमा चेक गर्छौं. सो नाउ A less than or equal to B cube. So let us put A is equal to half, B is equal to half. Half comma half should belong to the relation R. Let us check it. So therefore A is half less than or equal to, this is half whole cube, right? So half less than or equal to 1 by 8. Which one is greater here? Half is greater than 1 by 8. Okay? Is 1 by 8 greater than half? No. 1.2 भनेको 0.5. 1 by 2 भनेको कति हो? 0.5. 1 by 8 means 0 point something. 0.1 something, isn't it? 1 by 2 भनेको त्यो 0.5, 1 by 8 भनेको 0.1 something हुन्छ. जस्तै 2 ले 1 लाई डिभाइड गर्दा 2 ले 1 लाई जाँदैन 0 दियो, point लिएर 0 जानु, 2 5 जा 10. तो यो भयो 0.5. This is your 0.5. Less than or equal to 1 by 8 भनेको 8 ले 1 लाई डिभाइड गरिन्छ. 0.0 थप्नु यहाँ, 8 1 जा 8, 2 फेरि 0 झार्छ, 8 2 जा 16, 4 0, 8 5 जा 40. That is 0. This will be 0.125. Which one is greater in this case? Is 0.125 greater than 0.5? No. 0.5 is greater than 0.125. This is wrong. That means half comma half does not belong to the relation R. बुझ्यो? तर 2,2 त पर्दै छ, तर यो half comma half त परेन नि त. That is, it is not a reflexive relation. Is that clear? So I think you have understood it. You know that 0.5 is always greater than 0.125. यो 0.5 को पछाडि दुईटा 0 हाल्नु सक्छौ नि त. 500 भयो त नि त. 500 is greater than 125. Is that clear? So now in this case, what can we write here? In this case, we can write down that half comma half does not belong to this relation a less than or equal to b cube. So therefore, the relation R is not reflexive. The relation R is not reflexive. So I think you have understood it. Okay. Next. So I think you have understood it. Half comma half. Oh, sorry. It does not belong to the relation R. Half comma half does not belong to the relation R because this half comma half does not satisfy the relation a less than or equal to b cube. So that's why it is not a reflexive relation. Is that understood now? So next, अब हामी गर्छौं symmetric relation. Symmetric relation. So let us check for symmetric relation. Okay? So यो symmetric relation को definition के हो? A comma B belongs to the relation R implies that B comma A belongs to the relation R. Is that clear? A comma B belongs to the relation R should imply B comma A belongs to the relation R. Okay, now let us take A comma B. Let us take an example now. 1 comma 4. Okay, so 1 comma 4 such that A less than or equal to B cube. A less than or equal to B cube means A means 1, 1 less than or equal to 4 whole cube, which implies that 1 less than or equal to, what is 4 cube? It is 64. Naturally 64 is greater than 1. That is correct. Okay. So therefore 1 comma 4 belongs to the relation R. Is that clear? Now check for 4 comma 1. अब उल्टा check गर्नु पर्यो. Check for 4 comma 1. Check 4 comma 1. Check 4 comma 1 now. So check for 4 comma 1. Now 4 comma 1 such that 4 comma 1. A is 4 less than or equal to, what is B cube? 1 cube, which implies that 4 less than or equal to 1. Is it true? Is 4 less than 1? No, that is wrong. This is wrong relation. That means therefore 4 comma 1 does not belong to the relation R. So what can you say about the relation R? The relation R is not symmetric relation. Therefore the relation R is not symmetric. The relation R is not symmetric. So I think you have understood it. The relation R here is not a symmetric relation. Okay, so you can copy it. Now we will check for transitivity. So now let us check for transitive relation now. Now transitive relation. Transitive relation. Now let us check for transitive relation now. So what is the definition of transitive relation? If A comma B belongs to the relation R and B comma C belongs to the relation R, it implies that A comma C belongs to the relation R. Okay? So let us take an example here also. Let us take an example now. Now A comma B belongs to the relation R. You have to take the values of A and B in such a way that A less than or equal to B cube should be there. Okay? So now let us take A is equal to 3, B is equal to 3 by 2. Right? So 3 comma 3 by 2 such that 3 less than or equal to 3 by 2 whole cube. It should be true. Right? It should be true. So which is equal to 3 less than or equal to 3 cube is 27 divided by 2 cube is 8. Right? So which is equal to now next. Next one is 3 less than or equal to what is 27 by 8. 8 ले 27 लाई डिवाइड गर्दा 8 3s are 24, right? So 7 minus 4 is 3.0. 8 3s are 24. 8 3s are 24. 60. 8 7s are 56, like that. Okay. So approximately it is 3.37. Let us write it. 3.37. Obviously, this 3.37 is greater than 3, right? That means 3 comma 3 by 2 belongs to the relation R. Is that clear? I think you have understood it. Okay. So next, let us take. Now this is 3 comma 3 by 2. A is equal to 3, B is equal to 3 by 2. Now B should be 3 by 2. B should be what? 3 by 2. So A is equal to. Now in this case, A you should take it as 3 by 2 now. A you should take it as 3 by 2. And what is B? Let us take 6 by 5. Okay. Now, therefore, 3 by 2 comma 6 by 5 should belong to the relation R. यो पनि relation R मा हुनु पर्छ. बुझ्नुभयो हैन? So, such that now this is the relation A less than or equal to B cube. 3 by 2 less than or equal to 6 by 5 whole cube. Right? So which is equal to, this is 3 by 2 less than or equal to what is 6 cube? 216 divided by what is 5 cube? 125, right? This is 125. Which is equal to what is 3 by 2? 2 ones are 2.5. This is 1.5 less than or equal to. So let us check it now. Let us check it. Divide 216 by 125. 216, right? So it is 125. Let us subtract it. 6 minus 5 is 1. 6 minus 5 is 1. 11, 9.0. 7 times, isn't it? 7 5s are 35, 3, 7 2s are 14 plus 3 is 17, 7 1, 7 1 is 8. 7 5s are 35, 5 3, 7 2s are 14 plus 3 is 17, 1, 7 1 is 7 plus 1 is 8. Okay, approximately it is 1.7. This relation also holds good. That is 1.7 is greater than 1.5, right? So I think you have understood it. So in this case, this 3 by 2 comma 6 by 5 belongs to the relation R. Okay, so 3 comma 3 by 2 belongs to the relation R. 3 by 2 comma 6 by 5 belongs to the relation R. You same 3 by 2, 3 by 2. Now check for 3 comma 6 by 5. Therefore check for what? Check for what? This is 3 comma 3 by 2. 3 by 2 is same. B same. Now A comma C should belong to the relation R. So 3 comma 6 by 5 should belong to the relation R. Then it is transitive. Otherwise, it is not transitive. Okay. So now let us check it. 3 comma 6 by 5 satisfies the relation a less than or equal to b cube or not. Let us check it. So I think you have understood it. बुझ्दै छ होला तिमीले यो अलिकति अप्ठ्यारै छ यो तर घरमा प्र्याक्टिस गर्नु अलिक ठीक छ त्यही कारण म प्राय प्रब्लमहरु नै गर्दिन्दैछु पुरा एक्जाम्पलहरु गर्दिन्छु तिमीलाई सजिलो होस् भनेर ठीक छ नाउ यु हैव टु चेक फर 3,6 by 5 okay 3,6 by 5 now a is equal to 3 b is 6 by 5 such that a less than 3 less than or equal to b cube. What is b cube here? 6 by 5 whole cube. Okay. So which implies that 3 less than or equal to what is 6 cube? 6 cube is what? 216 divided what is 5 cube? This is 125. Which implies that 3 less than or equal to we just divided 216 by 125, isn't it? That was 1.7. 1.7. Does it all good? No. 3 is not less than 1.7. That is 3 is greater than 1.7. So this relation is not true. That means therefore 3 comma 6 by 5 does not belong to the relation R. Does not belong to the relation R. That is 3 comma 3 by 2 belongs to the relation R and 3 by 2 comma 6 by 5 belongs to the relation R, but 3 comma 6 by 5 does not belong to the relation R. So what can you say about the relation R? The relation R is not transitive relation. Therefore, the relation R is not a transitive relation. Is not a transitive relation. Is not a transitive relation. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now let's do this question number 9. So that the relation R in the set capital A is equal to within second bracket 1 comma 2 comma 3 given by R is equal to 1 comma 2 comma 2 comma 1 is symmetric but neither reflexive nor transitive. So you have to prove that this relation R is symmetric but neither reflexive nor transitive. Okay. So here given set A is equal to 1 comma 2 comma 3 and the given relation R is equal to 1 comma 2 comma 2 comma 1. So you have to prove that this is not reflexive. For reflexive, from the set A 1 comma 2 comma 3, for reflexive you must have 1 comma 1 2 comma 2 3 comma 3. Is it there? No. Since 1 comma 1 comma 2 comma 2 comma 3 does not belong to the relation R, therefore the relation R is not reflexive. The relation R is not reflexive. Is that clear now? So next, since 1 comma 2 belongs to the relation R implies that 2 comma 1 belongs to the relation R, so it is symmetric. 1 comma 2 ulta pulta, 2 comma 1 is also there, so it is symmetric relation. So therefore the relation R is symmetric relation. The relation R is symmetric relation. The relation R is symmetric relation. Okay. So is it transitive? Can you say that it is a transitive relation? If 1 comma 2 is there, 2 comma 1 is also there. So 1 comma 1 should be there. Is there 1 comma 1? No. Since 2 comma 1 is there and 1 comma 2 is there 2 comma 2? No. Okay. So in this case, now 1 comma 2 belongs to the relation R and 2 comma 1 belongs to the relation R, but 1 comma 1 does not belong to R. Is that clear? This 1 comma 1 does not belong to this R. Also 2 comma 1 is there. 1 comma 2 is in relation, 2 comma 1 is in relation, but 1 comma 1 is not in this relation. So it is not transitive. Okay. Also 2 comma 1 is there, 1 comma 2 is there, but 2 comma 2 does not belong to the relation R, and 2 comma 2 does not belong to the relation R. So the relation R is not transitive. So therefore the relation R is not transitive. Therefore the relation R is not transitive. So is that clear to all of you? So hence the relation R is symmetric. Hence the relation R is symmetric. Hence the relation R is symmetric, but neither reflexive nor transitive. So it is proved. Hence we have proved the relation, that is the relation R is symmetric. The relation R is symmetric but neither reflexive nor transitive. Okay, so I think you have understood it. So you can copy it. We'll do the next problem now. So now we'll do question number 10, that is set A is given as 1, 2, 3, 4, 5. Okay. So these 1, 2, 3, 4, 5 are the members of the set A, right? And also the relation R is given, that is A, B. All these A, B belongs to the set A. So in this case, R is a relation A, B belongs to the relation R such that within mod A minus B is always even. A minus B is always even, right? So that R is an equivalence relation. You have to prove that R is an equivalence relation. Okay? And also you have to show that all the elements of 1, 3, 5 are related to each other. That means 1, 3, 5 are related to each other means that A minus B is even. A minus B say even honu parcha. Within mod A minus B should be even. You know that they are related to each other. That is 1 minus 3. Within mod 1 minus 3 is 2. That is even. Within mod 3 minus 5 is 2. That is also even. Within mod 1 minus 5 that is also 4. That is also even. They are related to each other. And similarly all elements of 2, 4 are also related to each other. That is within mod 2 minus 4 is equal to 2. That is your even. So within mod 4 minus 2 is also 2, that is also even. That means all the elements of 2, 4 are related to each other. Okay. But no elements of 1, 3, 5 is related to any element of 2, 4. So you know that if you subtract 1 minus 2, within mod 1 minus 2 means 1 odd. We are not getting even. 4 minus 1 is also 1. 2 minus 3 is also 1. 4 minus 5 is also 1. So this even number minus odd number is always odd number. This even number minus odd number will always be an odd number. So we are not getting even number here. So no element of this 1, 3, 5 is related to any element of 2, 4. So we will do this second part later. Okay. So first let's prove that R is an equivalence relation. Okay. So this is your first part. This is your first part answer. So now for reflexive relation, you should prove that A, A belongs to the relation R. Okay. So therefore here A, A such that here A, A means A may be 1, 2, 3, 4, 5. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay. So here within mod a minus a is equal to within mod 0 is equal to 0 is an even number. 0 is an even number. You can take 0 as an even number, right? You can take 0 as an even number. So therefore, the relation R is reflexive. The relation R is reflexive. Here the relation R is what? It is reflexive. Okay. So now second part. So second part is, what is the second part? For symmetric relation, if A comma B belongs to the relation R should imply that B comma A should belong to the relation R. Is that clear now? So in this case, if A comma B belongs to relation R, so that is, if A comma B belongs to the relation R, then A minus B is even. A minus B is even, which implies that ulta pulta garnu saksau तिमीले. So B minus A पनि के हुन्छ यो? Is also even. So B minus A is also even, which implies that if A comma B belongs to the relation R, then B comma A should belong to the relation R. If A minus B is even, then within mod B minus A is also even, right? Suppose 1 minus 3 is there. 1 minus 3 within mod 1 minus 3 भनेको 2. The 3 minus 1 पनि के हुन्छ? Within mod 3 minus 1 भने 2 is also even. So it is done. Okay. So therefore the relation R is symmetric. The relation R is what? It is a symmetric relation. It is a symmetric relation. So I think you have understood it. Okay. So next you have to check for transitivity. This is not your second part. Your first part ko answer ho. This is the answer for the first part, right? But this is your symmetric relation. Now for transitive relation. Now for transitive relation, if A comma B belongs to the relation R and B comma C belongs to the relation R, which should imply that A comma C belongs to the relation R. Okay. So if A comma B belongs to the relation R, then you can write down this one. Therefore A minus B is even, right? A minus B is what? Even. Okay. If B comma C belongs to the relation R, then B minus C is also even. So B minus C is even. Then B minus C is also even, right? So A minus B should be positive, B minus C should also be positive because they are put within modulus sign. So we can write here, if we can add them, we can add them, isn't it? A minus B is an even number. Whether it is positive or negative, it is an even number. Whether it is plus 2 or minus 2, it is an even number, right? So let us add them, A minus B plus B minus C. So even number plus even number is equal to even number. Even integer plus even integer is equal to even integer. You know that, isn't it? That even integer plus even integer is equal to even integer, isn't it? This A minus B is even integer, B minus C is also even integer. Even integer plus even integer is equal to even integer. Is that clear to all of you? So we are adding them. So BB gets cancelled, which is equal to A minus C is an even integer. Is an even integer. So you may put it within mod sign also. So A minus C is an even integer. That means A comma C also belongs to the relation R. So what can we say? That is even integer plus even integer is also an even integer. That is within mod A minus C is also an even integer. Okay. So therefore the relation R is a transitive relation. The relation R is a transitive relation. Is a transitive relation. So we have proved that the relation R is reflexive, symmetric and transitive relation. So hence the relation R is an equivalence relation. The relation R is an equivalence relation. Hence the relation R is an equivalence relation, so it is proved. So I think you have understood it. Okay, so we have shown that R is an equivalence relation. Now we have to show that all elements of within second bracket 1, 3, 5 are related to each other. So 1, 3, 5 are related to each other. So that is within mod 1 minus 3 is equal to 2. That is an even number, which is an even number, isn't it? So within mod 3 minus 5, which is also 2, that is also an even number. So we are getting this even number, isn't it? We are getting even number. We can write 1 minus 5 also, which is equal to 4. That is also even number. That is also even number. Okay? That is, all these are odd number, isn't it? So odd number minus odd number is also even number. It indicates that, which implies that odd number minus odd number will always give you even number. That means they are related to each other. Hence 1, 3, 5 are related to each other. Are related to each other. Are related to each other. Is that clear now? Next, you have to prove that 2, 4 are also related to each other. That is, their difference should be even again, right? So, let us take 2, 4, which implies that within mod 2 minus 4 is equal to 2. This is also an even number, right? Which implies that within mod 4 minus 2 is also 2, which is also an even number, right? That means even number minus even number is equal to even number. Even number minus even number is equal to even number, right? So which implies that even number minus even number is equal to what? Even number. Is that clear to all of you? So you can write hence, you can write here hence 2, 4 are also related to each other. Hence 2, 4 all elements of hence all elements of 2, 4 are also related to each other. Are also related to each other. Okay, so यहाँ पनि त्यसै लेख्ने hence all elements of, right? Hence all elements of 1, 3, 5 are related to each other. Okay, so यो चाहिँ was second part को answer, यो चाहिँ was third part को answer, right? So that all elements of 1, 3, 5 are related to each other. यो के को answer भयो? This is the answer for the second part. This is answer for the third part. Now fourth part. But no elements of 1, 3, 5 is related to any element of 2, 4. That is your even number, your odd number. This is even number. What is odd number minus even number? Odd number minus even number will always give you the odd number. Odd number भनेपछि तिमीले के लिन्छौ? 3 लिन्छौ. Even number भनेपछि -4 ले भने के भयो? Which is equal to 1, which is an odd number, isn't it? So you can write that is, but no elements of 1, 3, 5 is related to any element of 2, 4. That is, this is your odd number and this is your even number. So you know that odd number minus even number will give you what? Odd number minus even number will give you odd number. Is that clear? Is that clear? That is 1 minus 2 is 1, 3 minus 4 is 1, 5 minus 4 is 1, 3 minus 2 is 1, 5 minus 2 is 1. त तिमीले योबाट कुनै पनि नम्बर यो नम्बरबाट घटाउँदाखेरि के हुन्छ? You will get odd number, isn't it? यो नम्बरको कुनै पनि नम्बरबाट माइनस गर्यो भने तिमीमा के आउँछ? जहिले पनि odd number आउँछ. That is odd number odd number minus even number will give you odd number. So which is not true in this case, isn't it? यहाँ त a minus b के आउँछ भन्दैछ even, तर we are getting odd number, isn't it? Hence no elements of 1, 3, 5 is related to any element of 2, 4. So hence no element of 1, 3, 5 is related to any element of within second bracket 2, 4. Is that clear now? That is, यहाँ के भन्नु खोजेको भन्दाखेरि within mod भित्र subtraction गरेर that is always positive. So 1 minus 2 is within mod, eh? 1 minus 2 is 1, that is odd. 1 minus 4 is 3, that is odd. 3 minus 2 is 1, that is odd. 3 minus 4 is 1, that is odd. 5 minus 2 is 3, that is odd. 5 minus 4 is 1, that is odd. We are not getting this even. Here it is defined as even. So no elements of these sets, that is 1, 3, 5 is related to any element of this set 2, 4. Is that clear now? So you can revise it at home. So we'll do the next problem now. So now let's do this question number 11. So that the relation R in the set capital A is equal to, within second bracket, x belongs to z. Z means integers, where 0 less than or equal to x less than or equal to 12. That means x is greater than or equal to 0 but less than or equal to 12. That means 0, 1, 2, 3, 4, 5 up to 12. You can take it. Okay. Given by number 1, capital R is equal to small a comma small b such that within mod a minus b is a multiple of 4. So this relation R a comma b such that within mod a minus b is a multiple of 4. Right? So number 2, capital R is equal to within second bracket a comma b, within second bracket a comma b such that a is equal to b, are equivalence relation. You have to prove that these two, number 1 and number 2 relations are equivalence relation. Okay. So also you have to find out the set of all the elements related to 1 in each case. You have to find the set of all the elements related to 1 in each case. Okay. You have to find out the set of all elements related to 1 in each case. Okay. So now let us do number 1 first. You have to show that it is an equivalence relation. So 11 number 1. Okay, that is R is equal to within second bracket a comma b such that a minus b is a multiple of 4. Right? So for reflexive relation, relation a comma a should belong to the relation R. That is a comma a such that a minus a is equal to within mod 0 is equal to 0. Obviously 0 is divisible by 4. You know that 0 is divisible by 4, isn't it? That is 0 is a multiple of 4. 0 is a multiple of 4 because 4 into 0 is 0. That is multiple of 4 is divisible by 4. 0 is divisible by 4, isn't it? So therefore the relation R is a reflexive relation. Therefore the relation R is a reflexive relation. Therefore the relation R is a reflexive relation. Is that understood? So now this is your reflexive relation. Okay, so the relation R is a reflexive relation. We have proved that R is a reflexive relation, right? अब लेख्छौं हामी for symmetric relation. For symmetric relation, What can we write for symmetric relation? If A comma B belongs to the relation R implies that B comma A belongs to the relation R. That is, therefore A comma B. Therefore A comma B such that A minus B is a multiple of 4. Is a multiple of 4. That means अब यसलाई उल्टा गर्दा फेरि के हुन्छ? That is B comma A. B comma A such that B minus A उल्टा भइगयो यो. Like 5 minus 1. 5 minus 1 is 4. 5 minus 1 is 4. 4 is a multiple of 4, isn't it? 4 is a multiple of 4. Right? Or you may write 9 minus 1. 9 minus 1. 9 and 1. 9 minus 1 is 8. Isn't it? A is equal to 9, B is equal to 1. 9 minus 1 is 8. 8 is a multiple of 4. 4 to the 8. Okay? So can you write 1 minus 9? So what is within mod 1 minus 9? That is also 8 is a multiple of 4. So we can write within mod B minus A is a multiple of 4. Is a multiple of 4. That means A comma B belongs to R implies that B comma A belongs to the relation R. Hence the relation R is a symmetric relation. 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 So I think you have understood it. Okay. So now let us check for the transitivity. For transitive relation, let us check it now. So you can copy it. Now we will check for transitivity. Now let us check for transitive relation. For transitive relation, we have if A comma B belongs to the relation R and B comma C belongs to the relation R, it should imply that A comma C belongs to the relation R. Okay. So therefore A comma B means such that A minus B within mod A minus B is a multiple of 4. Is a multiple of 4. Right. So that is, we can write A minus B is equal to 4k. Because it is a multiple of 4, you can write 4k where k is any integer, right? Where k is any integer. Where k is any integer. Where k is any integer. Okay. So again B comma C such that B minus C is a multiple of 4. Is a multiple of 4. Right. That means we can write within mod B minus C is equal to 4m. Where m is an integer. Where m is an integer. Where m is an integer. Right. So here A minus B is equal to 4k. Right. So don't write this mod sign because it is positive, okay, and B minus C is also 4m. Let us add them. So if you add them, BB gets cancelled. So A minus C is equal to 4 within bracket k plus m. So it should be always positive. So within mod you write 4 within bracket k plus m, where k plus m is an integer, right? K plus m is an integer. K plus m is an integer. Is that clear? So hence within mod A minus C, hence within mod A minus C is a multiple of 4. Is a multiple of 4. Or you may write is divisible by 4 also. Is that clear? So if A comma B belongs to the relation R and B comma C belongs to the relation R, then A comma C belongs to R. So therefore A comma C belongs to R. Hence R is a transitive relation. Hence R is a transitive relation. Hence R is a transitive relation. Is that clear? So R is reflexive, symmetric and transitive, hence R is an equivalence relation. So here you can write, hence R is an equivalence, hence R is an equivalence relation. So I think you have understood it. So you can copy it. So now we'll do the next question. Now next part, that is second part. So you can copy it. You can pause the video and then you can copy it. Okay. So now let's do the second part. So let's do the second part here. So what is the second part? R is equal to within second bracket A comma B such that A is equal to B. It should be an equivalence relation, okay, for a reflexive relation. For reflexive relation we have A comma A should belong to the relation R. Okay, so you know that A comma A such that A is equal to A, isn't it? A is equal to A, A is equal to A. Obviously it is A is equal to A, right? For A comma A is equal to A. So therefore the relation, so this relation R is a reflexive relation. The relation R is reflexive. The relation R is reflexive. Is that clear? Next, for symmetric relation, what can you write? A comma B belongs to the relation R implies that B comma A belongs to the relation R. Okay, that is A comma B implies that such that A is equal to B. So B comma A such that ulta pulta lekhna saksau feri, ulta lekhna saksau, that is B is equal to A. It is also correct. So hence R is a symmetric relation. So we can write here, hence R is a symmetric relation. Hence R is a symmetric. Hence R is a symmetric relation. Okay. Now transitive relation. For transitive relation, what can you write for transitive relation? A comma B belongs to the relation R and B comma C belongs to the relation R implies that A comma C belongs to the relation R. Okay. Now in this case, A comma B such that A is equal to B is given. So A comma B such that A is equal to B is given. Now B comma C belongs to relation means B comma C, which implies that B is equal to C. That is, if A is equal to B, then B is equal to C, which implies that A is equal to C, isn't it? That is, A comma C also belongs to the relation R. So if A is equal to B and B is equal to C, then obviously A is equal to C, isn't it? So that is A comma C belongs to the relation R. So therefore the relation R is what? Transitive. Therefore the relation R is transitive. Is that understood? So I think I've understood it. Okay. So here R is reflexive, symmetric and transitive. Hence R is an equivalence relation. Hence in number 2 also, hence the relation R is an equivalence relation. Hence the relation R is an equivalence relation. So I think you have understood it. So this is the answer for this first one and second one. Now last part. Find the set of all elements related to 1 in each case. And each case number 1. In each case means for number 1, you have to find out set of all elements related to 1, isn't it? So elements, that is set of elements related to 1. Set of elements related to 1 is equal to, within second bracket, so set of all the elements related to 1. Set of all elements related to 1, in that case 0 less than or equal to x less than or equal to 12 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which are the numbers related to 1 such that it is a multiple of 4? That is 1 minus 1 is 0, that is a multiple of 4. So this is 1. 1 minus 1 is what? 0. 0 is a multiple of 4. Then comes what? At 4 here, it should be multiple of 4, isn't it? At 4 here, 4 plus 1 is 5. That is 4 plus 1 is 5, right? So 5 minus 1 is what? 4, or 1 minus 5 is 4. That is 4 is a multiple of 4. Then comes what? 9. 9 minus 1 is 4. 9 minus 1 is 8. 9 minus 1 is 8, or 1 minus 9 is 8. That is a multiple of 4. That is 9. So set of elements related to 1. Set of elements related to 1 for the first problem. Related to 1 for first problem. For first problem, 1 is equal to, how much is it? 1, 5, 9. Right? And for number 2, set of elements related to 1 for second problem. For second problem means this number 2. So set of elements related to 1 for second problem number 2, that is A is equal to B. A is equal to B should be there. That means 1 is equal to 1. 1 is equal to 2 पनि हुँदैन, 1 is equal to 3 पनि हुँदैन, 1 is equal to 4, 1 is equal to 12 हुँदैन, खाली 1 is equal to 1 मात्रै हुन्छ. So for number 2, it is only number 1. So I think you have understood it. That is set of elements related to 1 for second problem number 2. That is A is equal to B should be there. So 1 is equal to 1 मात्रै त हुन्छ, अरु हुन्छ 1 is equal to 2, 1 is equal to 3, 1 is equal to 12 हुँदैन कुनै पनि. So it is 1 is equal to 1. So set of elements related to 1 for second problem number 2 is, within second bracket, it is 1. So I think you have understood it. So this much is for today. त आज पनि हामीले यही 5 वटा प्रब्लमहरु गर्यौं. यो घरमा राम्रोसँग रिभिजन गर्नु, यसलाई बुझ्ने चेष्टा गर्नु, बुझेन? त नेक्स्ट अनलाइन क्लासमा चाहिँ म अझै तिमीलाई यस्तै प्रब्लम्सहरु देखाउने छु. So this much is for today.